Alright guys, welcome to Saket Academy, and we're gonna do the homework 19 through 26. Alright, let's start on number 19.
Can I draw?
Alright, number 19.
6 kilogram block slides along horizontal surface.
That's not a big tip, right? Shape.
Okay, Mia.
If the static friction, the coefficient is 0.2 for the block and surface, what rate is the friction force doing work on the block at an instant when its speed is 4 meters per second?
Power's the rate of change of the work, so that's basically what we're trying to find. We're trying to find power. And so power is equal to work times
Time.
over time.
Over time, yeah.
And so that's also equal to force.
Oh, don't press the buttons on that. Okay, let me do it for you.
Give the equation sheet.
Shoot it. I'll pull it up. Hold on.
And we do the physical equation sheet.
I'll.
Does no one have the equation sheet in this house?
Okay, hold up. Here you go. This one, right?
Yeah, P equals F.
You have to click again. Don't press the buttons.
Like just.
Yeah. Yeah, you're good. Equals.
Or we could give Totoro mushrooms around him. So he's like psychedelic mushrooms, you know? He consumes them and he has like
What's mu?
Mu is 0.2.
Make me some mushrooms.
So it's just like 60 times
So that's gonna
0.2.
be 11.772, and that's times our velocity.
Which is 4.
Such a bad example. Now.
47.09 watts.
Am I crazy? This is the same thing.
Amazing. Alright, let's see.
And it would be,
47.09. That's B.
and then what happens here is that the friction force would actually be
Negative.
because
Because it's
this
slowing
block
down
would
the
slide-
block.
Yeah.
Alright, let's do number 20 now. Hold on, let me switch it in the... Alright, number 20. At what rate is the gravitational force on a whatever? Okay, you know the deal. Let me switch the window capture. Alright, press here and then drag that up. Alright, let me pull up the problem. Hold on. Saket Academy.
And
Alright.
so it begins.
At what rate is the gravitational force on a 2 kilogram projectile doing work at an instant when the velocity of the projectile is 4 meters a second directed 30 degrees above the horizontal?
So our V here is 30 degrees, and so the vertical component of the velocity is going to be
4 sine
V
30.
sine theta.
And then
That's equal to 2. And so then P is equal to F times P is equal to 2 times F equals 2 times 6, 2 times 2 times G. Sorry. That's going to give you about negative 40 watts.
and that is answer choice C.
It's alright. I'll classify.
Alrighty, on to number 21. Alright. Okay, no, let's just not bother showing the question. You already know. You already know the deal, guys.
2 kilogram block slides down a plane inclined 40 degrees with the horizontal at a constant speed of 5 meters per second. At what rate is the gravitational force on the block doing work? So F equals to just mg in this situation, but we can also take F down the ramp equal to mg sine theta. And so that's equal to
When I see you, I kind of feel sad, but I'm also happy.
Do the math on your calculator, guys.
12.61 newtons times 5 meters per second, giving us positive 63
Which
watts.
is answer choice B.
They're all gone.
Alright, hold on a sec.
Listen, Cholo, where did the
Okay, scroll down. Alright, number 22.
What?
The speed of a 4 kilogram object is given by V equals 2t meters per second, where t is in seconds. At what rate is the resultant force on this object doing work at t equals 1?
So F here equals to MA equals to mdv dt equals to m times 2. That's going to be equal to 8 newtons. And V evaluated at t equals to 1 equals to 2 meters per second.
So 8 times 2. And you get 16, which is answer choice E. Alright, next question, number 23. A 3 kilogram block is on a frictionless horizontal surface. The block is at rest when, at t equals 0, a force of magnitude P equals 2.0 newtons, acting at an angle 22 above the horizontal, is applied to the block. At what rate is the force P doing work at t equals 2 seconds?
So obviously our block isn't going to be flying, so at t equals to 2,
all drawn on the board in like discrete.
V is equal to a t, A is equal to
2.
F
Wait,
cosine theta
Okay, so like
over
kind of like
m.
draw like a
So that's going to give
little
us
he's kind of like discrete.
so 2
2
cosine.
cosine 22 over 3.
Yes. So 2/3 cosine 22.
That's true.
The extra secret, he just erased.
A equals
Or we can just draw the
0.6181. So V at t equals to 2 seconds equals A times 2.
2a.
V equals to 1.236. And F is equal to
2
F
newtons.
cosine theta.
Come on, Encore. Let's your comprehension.
So 1.236 times 2,
2 cosine
cosine 22,
22.
gives us 2.3 watts.
Which is answer choice A.
No, I mean,
I remember this question.
Alright, now on to question 24. A 1.6 kilogram block slides down a plane incline at 25 degrees the horizontal at a constant speed of 2 meters per second. At what rate is the frictional force doing work on the block? So you've got your main force as, let's see,
So
friction.
what we can do here is the rate of the frictional force. So Fn equals to mg cosine theta. And so F of Fr equals to mu Fn. That's going to be mu mg cosine theta 1.6 cosine 25 9.81 times
Well, the thing is, mg sine theta equals the frictional force because it's not accelerating, right?
yeah, that's true. So mg sine
Then you have to solve for mu.
so actually what you could do also is because this is equal to FFR
What's Ray up to?
times V equals to
Hey, Saket.
yeah
What's Ray up to? Why do I never see him?
nothing. We're all stars.
Oh wait, so it's mg sine theta times v. So 2mg
Giving
sine
you
theta,
negative 13 watts.
and that is answer choice C.
Sorry about the fumbling.
All right, on to question 25. All right. Give me a second.
I know he has externship.
Externship is students are good.
Alright. A 3 kilogram block is on a horizontal
Is
surface.
library periods.
The block is at rest when, at t equals 0, a force, magnitude of 12, acting parallel to the surface is applied to the block, causing it to accelerate. The coefficient of friction between the block and surface is 0.2. At what rate is the force P doing work on the block at t equals 2 seconds?
For what?
So power
What?
equals to
The
the
test is on Thursday?
force times the
But we had a
velocity.
test today.
Yes.
And so our force is easy to find. It's going to be 12 newtons. So now our velocity is going to be a bit harder. V equals AT.
You need to solve for A, and
A
MA equals the force applied minus the frictional force. So, what is it? 12.
mg mu.
So
so-
it's
3 times 9.81.
well, you gotta tell them where you got that.
So that's going to be our A is equal to the force applied minus the frictional force, force FR.
Yeah. So it's 0.2 times 12, right?
No, it's going to be 0.2
Or- oh, wait,
times
sorry.
3 times g.
I forgot.
0.2 times 9.81 times.
Guys, I did it
3.
stupid. I'm sorry.
So our A is going to be equal to 6 meters per second. 6 newtons over m1 is equal to 2 meters per second squared. So V of final equals to 2 times 2 equals to 4. So it's going to be 12 times 4 for an approximate of 48 watts. So that's going to give us answer choice B.
Alright, now on 26, starting from rest at t equals 0, a 5 kilogram block is pulled across a horizontal surface by a constant horizontal force having a magnitude of 12 newtons. If the coefficient of friction between the block and the surface is 0.2, at what rate is a 12 newton force doing work at t equals 5? So this is around the same thing as 25.
Yeah, so this is going to be the same thing. And so in this question, what we're going to do is F equals MA. So F equals to F net equals to F applied minus F FR.
So
And so A equals FA minus mg mu over mass, which is going to be 5. And so 12 minus
minus
5.
0.2,
0.2 times g.
yes,
So
over 5, which you can cancel out that. No, you can't. I lied.
You should drive in Maury. Okay. You want to Maury? Yeah, that's my last task.
Yeah.
And when you solve,
A equals to 0.438. And so V equals to AT,
and 0.438
0.438 times 5, 2.19.
Oh my god.
times 12
I love that so much.
Equals to about
26. About 26. We're just guessing here. Right?
yes, 26 watts.
Yeah, so that'd be answer choice D. Alright. Thanks for tuning into Saket Academy. We'll see you tomorrow.